to reply by?
To GMIT. Anyone always.
Yeah. Okay. Right.
That's how it would work.
Like if I do GMIT, I just
got both the offers. If you want GMIT,
But
you have to pay.
dude,
Oh.
they can't expect you to get the results before the school releases them. They can't say, oh, you don't have them by the 2nd of August, why not? Like, because the school didn't give them to me.
thing is, they want 2,000, like, or
You have to
Now there's the real issue. They want cash.
yeah.
And you don't want to give them cash in case you don't get it.
No, in case I get anyone going.
Oh, I see, okay.
What's
Because
that?
then you'll lose your 2 grand.
Yeah.
Okay, so then you need to discreetly come around sometime.
Once you get NUI Galway before the 3rd of August.
You get your results, and then it's a conditional offer. You get your results.
You mean, you don't get the more marks? Okay.
Yeah.
I thought
I
you
got a
can still
conditional
waiting for
offer
that.
and they asked me to pay the full amount.
You got a conditional offer and they asked the full amount? That's
That's
scumbag.
Where is
That's
it?
refundable.
It's refundable.
Is it refundable?
GMIT boundary.
No.
No, the 2,000 is not refundable.
How much though?
But
It's the name of the college in GC.
DCU was,
Yeah.
In Dublin? Yeah, probably DCU then.
And you has one medical?
yeah, it's like
What's the grade the FAS they offer? Which grade do they? Which one? GMS.
C, D.
What did they offer you?
What's
Which
the
one?
IG?
The one in here, Dublin.
Yeah.
DC. But I'm also applied to ACM.
Okay, we'll continue. We'll continue now. Radioactive decay. We can have a look at those questions in the next class after you try them. Radioactive decay equations. We'll get a start on this. Continue. Continue, guys, have this?
They do have one extension.
Continuing. Alright, so radioactive decay equations. So as we noticed, we didn't really have any equations in the last lesson. Right, this is uranium. Looks great. Don't eat it. Quite dangerous, quite dangerous. We learned that radioactive isotopes like uranium will decay. The energy is released via alpha, beta and gamma radiation. But how can we detect this radiation? In fact, all these forms of radiation are colourless, you can't see it, odourless, can't smell it, tasteless, don't even think about doing this, you can't taste it,
Poison.
and chemically inert.
Oh, that's been trying.
Yes, so this won't cause a chemical reaction. So this actually is a little bit of a problem, since we kind of want to know if we have radiation. How can we know if we have radiation if we can't see it, smell it, taste it, or have it react with something?
Can't it initiate a reaction?
Yeah, well, this is what we'll look at. Not a chemical reaction. Chemically inert. It won't react with an acid or a base.
Yeah, but then can it, like, if you have to add one acid and base, can it, like, initiate, like,
No,
get
chemically
the
inert.
energy?
No. No. It's worth noting these 4 facts that alpha, beta, gamma are colourless, odourless, tasteless and inert. Chemically inert.
So if you lick an electron, you won't taste it.
No, I didn't say that. I said if you lick a radioactive substance, if you taste anything, it's not the radiation. You know, like if you drop the uranium on the ground, you might be tasting poop. I don't know. The radiation part won't taste like anything. But I welcome you to test it out.
Yeah, I think always don't have it.
No, alpha and beta particles are particles. Gamma waves are waves. Cold for one? Yes? Really? It must be like 12 outside. Oh, no breakfast, no fuel, no energy, huh? Why no breakfast?
Nothing to eat.
Nothing.
Nothing.
Not in the whole house.
Let's have the
Somalia.
cereal.
So what?
What is the honey cereal? I would like.
Oh, so you had your choice. Go to school hungry or eat honey cereal. Hunger sounds better.
And it's like for old for a long time.
It's old cereal.
Yeah.
Ah.
I feel like if I eat that, I will have something in the belly.
No. These things usually don't kill you. Usually.
It's too old.
Too old. Did it smell bad? Did it still smell like
No,
honey?
but I can feel more than 1 month.
Oh, just one month.
More than.
Oh.
I bought one for 3 months.
I thought years.
I think it would still be good after.
Chocolate, you have been the last of chocolate from 2016.
Like
Fire.
together.
Still good?
Let's stick together.
Oh, it's sticking together.
Because it has honey in it.
Okay. It's very important we know how to detect radiation since it's so dangerous. How can we detect it? Well, before we get into detecting it, what is it that we are trying to detect? So we are trying to detect activity. What exactly do I mean when I say activity? Activity is the rate at which the nuclei decays. So, yeah. Yes. So, for example, if this here has alpha, beta, and gamma coming off very fast, we say it decays quickly. But if the alpha comes off and then a long time later the beta and then another alpha, then this decays slowly. So activity is what we want to measure, how quickly it's decaying. And activity is defined as the rate of disintegration. Please note that would be definitely an exam definition. Got that? Excuse me while I check my email. Synchronizing email. Synchronizing.
Oh, your phone uses that word.
Synchronizing. So synchronizing. Alright, we'll continue it. Oh, opening folder.
Oh.
Oh, just one message from somebody I don't care about. And not only that, they sometimes get my name wrong as well. The email, like, Dear Thomas. Don't even care. Right. The way we measure activity is using this unit called Becquerel or BQ, because I don't know how to say it since it's a French dude. So the BQ. Yes.
Big go back.
Oh, sounds terrible. So the BQ is defined as, it's an SI unit for radioactivity, and it's defined as 1 BQ is 1 destruction of 1 nucleus per second. So when you destroy 1 nucleus in 1 second, that's a BQ.
It's as defined as.
Huh?
It's as defined as.
The BQ is the SI derived unit of
Where did
radioactivity.
you read that from?
You read the top.
Oh, the 1BQ is as. Oh, excuse me, I'm so sorry, my grammar. 1BQ is defined as. No, not is as. That's not anything. You guys are so picky.
Excuse our EAP skills.
Maybe I put this in to see if you can spot grammar mistakes. Maybe. Is as true?
Is it?
Is as true? Okay, continue. You have this? In other words, when one nucleus is destroyed, we have a 1BQ. Now, listen, I should really say, we have to be careful with the signs. So, if you don't know, it's a bit like if I said acceleration and deceleration. If I say deceleration, I don't need to tell you it's a minus. You know it's a minus because I said deceleration. Same deal for activity. If I say it's being destroyed, then you know it's losing one. So really it's a minus, but I don't need to tell you it. Yes? Okay. Right. Yeah. Like deceleration. A represents activity and the units are BQ. For example, 5 kilo BQ. What would that mean?
5,000 times destroyed in 1 second.
In 1 second, yeah. N represents number of atoms, e.g. 10 to the 6 atoms. Sometimes I or others are careless with the A. Really A is a negative when it's being destroyed, but just like with acceleration, we can drop the minus if we use the right words. The activity rate for destructions of atoms is 5 kilo equals. That clearly means I'm losing 5,000 a second, not gaining. So, if you want, you can think about the activity rate is minus 5. Focus, guys, what's going on? Calculating N is not too difficult. You learned how to do this in materials. PV equals nRT and all of that. In fact, you learned how to do this in chemistry too. 12 grams of carbon. How many carbon atoms do I have?
23.
I have 23 carbon atoms when I have 12 grams of carbon. Those are big, mother blanking carbon atoms.
12 times 6.6 times 10 to the power of 23.
No 12. Right?
Not 12.
Correct? Not 12?
Yeah. You said 12 times this number.
No,
Yes,
I meant
we all heard it.
of carbon.
What?
12 grams of carbon
Yeah.
equals 6.
No, that's not how we heard it. I'm pretty sure we heard 12 times 6, didn't we?
Yeah.
Even Fuang saying
12
yes.
times 1 gram of carbon equals 6.
Anyway, you did this in
Whoa! Nice.
chemistry. Is it? Now my speakers are
Football player.
broken, but we'll give it a try. Let me turn these on. The sound's not great, so listen carefully. Yeah, bye so.
John is over.
Look, leave Lee alone, even if he is racist, okay?
Yeah, we have someone in common. Right?
Oh, good. I'm glad you can come together on these things. Right, listen.
From my phone.
No, they are broken. Maybe someone can get the original sound from
Yeah,
Wikipedia.
yeah.
Type in Geiger_panic.
Stereo.
Can you get it there yet?
Geiger.
You have it?
What's it called?
There's Geiger panic. It's a sound file. It's on Wikipedia. I'm sure you'll easily find it.
What shall I YouTube?
No, it was on. No, just type in Geiger sound effect. Oh wait, he has it. Listen. You have it too? Yeah. That's it.
Oh, that was the same.
So it doesn't
Oh,
go.
where is it?
Not so bad.
This is Morse code.
Yeah, now listen to... Have you ever heard these before?
Yes.
You have?
It's not a Morse code, don't worry.
Morse code, not Morse code. That's quite different. No, it's not this. It's not this. Now,
Just under big tree, cat coming.
okay, you can stop that now. Thank you.
You can bark to it.
Now, this
Not even basic code.
Faisal. Stop Geigering, please. Now, this here is called a Geiger-Muller Counter, or just Geiger Counter for short, with screw Muller.
Geiger-Muller.
Yes.
Muller.
Muller, not Muller.
Oh, not like the yogurt.
It's German and very
Faisal, tone it down there now, tone it down. You're crossing the line again. Geiger Counter. You might have heard of these.
Mini.
What?
Mini.
What?
It's mini.
Yeah, because it's a mini counter.
Yeah.
Right. This is a Geiger counter, and these you might have seen on TV before. It's used to detect radiation, and it clicks when there's radiation nearby.
Is it the same thing that they find? No.
It's kind of a similar idea. It clicks when it's present. Yeah. So it's called a Geiger counter. Now, how does it work? Well, let's have a look at the diagram now.
Oh, yes.
It's not actually that difficult of a machine. I'll explain how it works. You have this special window here called a mica window. Now, this material is transparent. It's extremely fragile. It allows the radiation into it, but it keeps the inside a vacuum. Now, what happens is the radiation comes in, and this is filled with some gas. I can't remember. I think it's something like helium or some gas. It's not important right now. This is filled with some gas, and the radiation comes in and hits the atom and ionizes the atom. Because you learned in chemistry, if you give enough energy to the atom, it will ionize, and what will be freed? An electron. Now, there's an electric field here between the anode and the cathode. The cathode is the negative and the anode is the positive plate. So, if this is the negative and this is the positive, which way is the field going? Pointing up, positive to negative, isn't it?
No, positive is cathode.
Did I have it backwards? But that's negative there. I think cathode's negative, isn't it? Negative there.
Cathode is positive.
But look at the picture, it's attached to the...
The picture is wrong.
Yeah, cathode is positive.
Cathode, coming on plus E. But no, wait. No, you're right. Because in the
Can someone Google this?
No, right. In the chemistry, what's it called?
Electrolysis?
And electrolysis, they convert
Opposite way?
the opposite ways, yes. Only electrolysis. This is right.
That's what I thought.
Maybe, okay.
And you do the track.
Because I'm thinking of cation.
Do the track there.
Possibly.
Yeah. Cation is not the same as cathode.
Cation is attracted to the cathode.
Positive ion.
Yeah.
Cation is a positive ion.
Okay, so the cathode is a negative plate,
Yeah.
and this is the positive. So anyways, when you have an electric field, these particles will move in the field and hit the plate. And this will alter the voltage. And this altering of the voltage is detected and what makes the click.
Yeah, so it's the field is going into the anode. Because the anode is the positive.
Mhm.
You said it's going
Oh,
upwards.
sorry, I said it backwards. I had the signs right, but my English backwards. So the cathode is
Another
negative.
one of you are trying to figure out if we get the English or not.
Yeah, something like that. Something like that. Let me draw this.
How does the cathode attract positive?
Hang on, I'm drawing it.
And electrolysis the other way around.
This one is the positive.
Only the people.
Guys, and on the outside is the negative. and the field goes from positive to negative. No, I was right, but I think it's the way you look at it. It goes from positive to negative, but there's actually two plates here.
What field goes from positive to negative?
The electric field, isn't it, when you draw the electric field?
Now it's all mixed.
Yeah, so if you have a small positive charge here, which way will it move?
Down.
Down. And if you have a small negative charge, it'll move up. And what happens is the radiation comes in, hits the atom, frees the electron, the positive part moves down, the negative moves up, and this affects the voltage. The voltage is affected, and it makes the click sound. Just like that.
So, the voltage is what makes the sound, not the electron.
You want to get the electron hitting.
No. Yeah, that wasn't the sound of an electron hitting the plate, yes. Yep. There is a little speaker here. Okay.
Couldn't they make it a nicer speaker?
What? Like radiation?
Yeah.
Radiation?
Yeah, like that, right.
I think it's for traditional reasons. Because what possibly would have happened is you might have had a little like bell that would ding when the voltage reached a certain level. I don't know. It's for cultural reasons. Okay. You don't need to draw this in the exam. It's okay.
This is like very little energy to make that sound or something.
Yeah. You want it to be portable too. Okay. So, the activity is proportional to the number of atoms. This means if you have twice as many radioactive atoms, then you will have twice the activity, obviously. The activity and the number of atoms are always decreasing. So as time goes by, you always have less atoms and less activity, because it's running out of energy. It's giving the energy away. Just like with a car. As time goes by, you have less fuel and can travel less distance, then it's reducing the time. Therefore, A is a negative number. Mathematically, we have A is equal to minus some constant times n, because they're proportional. And the lambda is a positive constant known as the decay constant. And what would be the unit for lambda? I want you, as a small exercise, work out the unit for lambda.
Meters.
Meters? I've never heard of
Meters.
meters?
Is it the length of wave?
Oh my
BQ
goodness.
over
Because it's the constant.
BQ over kilogram.
No,
grams,
it's a
kilograms.
constant.
Close, but no.
What do you
You're
want?
thinking. I want the units for lambda.
Okay. Is it newtons?
Oh, BQ per mole per kilograms.
Are you joking me, or are you being for real right now? Say again?
BQ mole per kilogram.
No.
BQ per kilogram.
No.
What is
BQ per
what
gram.
is A?
It's big cube.
You're not listening. I said today what A is. French do it.
Okay, then the lambda is the same because n is just the number of atoms.
No.
Okay, then it's the same but per atom.
No.
Yes, it has to
No.
be.
No.
Then it's big cube.
No.
Okay, we don't know. Tell us.
You should know. If A equals lambda n with the minus, then the unit for lambda is A over n.
Whoa!
Wait, I'm not finished yet, Faisal. So what's the units for A?
BQ.
BQ. And the units for n? Atoms. What is a BQ? It's atoms per second destruction over atoms.
Whoa!
So it's per seconds, which is
Frequency. Nice.
Atoms or a unit?
like number of atoms, like moles.
Yeah, like 5 idiots. So,
Exactly, yeah. If you're counting in yahyas, yeah. So it's frequency.
why don't they just call it frequency?
It is yeah.
What? H said Hertz, yeah.
Yeah, no, really, why don't they just call it records?
Because it's decay constant. Because its purpose is to show you the activity proportionality constant with the n. It's only a consequence that has the same units as frequency. But it's the proportionality constant for A and N. Continue? Yeah. We'll go for a couple more minutes and finish. We'll push ourselves.
To the limit.
No, just
To infinity and beyond!
I am what? Like, how can you deal with it? Like, is this the first student to get that?
nobody's like Faisal.
Yes, exactly.
I don't like to comment on the mentally ill.
Okay, about this Mrs. Brown. I wanted to say this since I mentioned it.
Yeah?
Okay, so it was Valentine's Day, and Mrs. Brown was supposed to have a date,
Yes?
and then the date didn't show up.
Yes?
So her friend was like, "Your date didn't come,"
Yes?
and then Mrs. Brown was like, "He didn't arrive even."
Ah, Faisal. You were sitting there for the whole class wanting to tell me this.
Well, I didn't get this.
No, don't.
Your date
Yeah,
didn't
that's
come.
Faisal. Don't
He
see
didn't arrive
it.
yet.
Oh my god.
I don't know if it's good for you to watch this show. I think it might be destroying your brain further. Right. Good one though. Right, continue it.
Wait, A stands for
Activity. Okay. Now notice what the minus is for? To show that it's decreasing destructions. Okay, continuing. So what are the units of lambda? Right. In a radioactive sample, 1 mole of atoms is destroyed, or are destroyed.
No,
Is.
Because it's one more.
Yeah, English. Into alpha, beta, and gamma in 1 second. What is the activity of this? Okay, so it should only take you a few seconds. Give me the activity here. If 1 mole is destroyed in 1 second,
One.
you're not doing that thing I like you to do, which is think.
But it's one.
No, it's not.
Maybe.
No, it's not -1.
Because alpha and beta are not ones.
No.
PV equals M.
No.
No?
No.
I'll find M.
Stop being stupid, please. Everybody.
Number of moles equals mass over M.
Oh, it's 6.03
Minus.
23. The
Constant?
moles, yeah. Times
Yeah.
times.
The activity is 6 times 10 to the 23 destructions per second. Because how big is a mole? Yeah, 6 times whatever. And how much is being destroyed? 6 times whatever. So that's the activity. It's the number of atoms. With a minus. Yes.
But what's the decay constant?
Did I ask for the decay constant?
But don't you use the decay constant to get the activity?
Oh no, we'll look at an example like that in a moment. This is more basic than that.
Wait.
Now here's one you're talking about. You have 10 to the 10 atoms and 1,000 are being destroyed per second. What's the decay constant? Okay, now calculate that.
Can't we calculate it as atoms?
What?
The decay constant.
We just proved that the unit is Hertz.
Can't we calculate it as atoms? What does that have to do with it?
Calculate what? Yeah, you're supposed to use that.
Not multiply it by 6 times.
You mean to ask me, can't we calculate as moles, i.e. not multiplied by 6 times 10 to 23? And the answer is no, because the definitions are for atoms. No.
I'm losing it.
You are losing it.
10 to the minus 7.
Yeah.
Minus
Minus
one.
1 to the 7. No, what's that one? It's minus 1.
Hang on, now.
Minus 10 to the minus
A equals lambda n. So lambda equals minus A over n.
Yeah.
Now the n is pretty clear. What is it?
10 to the 10.
Now what's the A?
1,000.
Is it 1,000?
Yeah.
Or is it minus 1,000?
No.
Activity.
Why is it minus
But you already
1,000?
have a minus.
Yeah, but that's in the formula. That's not to do with the activity.
You told us the formula, the sign is there because of the decay is like it's decreasing.
Yeah, because it's decreasing. Yes.
So why do you do it twice? It's already there.
Or why is the minus here if this is already a minus?
Yeah.
Well, let me just put it this way to you. I have n equals A over minus lambda. This definitely has to be a positive. So if this is a
Okay.
negative, you know.
So it's 1.
In fact, Yusuf, the reason for the minus will become clearer later actually because it has something to do with ODEs. That's right, I said it, ODEs. Anyways, a little hint. Let me give you a hint here. Okay, guys? The hint here is, for us, lambda should always be a positive. So I kind of needed the two minuses here. So the answer is 10 to the minus 7 per second. Okay, continue. Continue. No energy left. No chocolate today? No chocolate? No biscuits? No granola bars? No apple, bread, banana?
Wait, I lost my bag.
What bag?
Handbag, the bag. I put the food inside.
You lost your food bag?
Yeah,
That's terrible.
in here. How to find it?
I wouldn't surprise me if one of these guys stole it. Did you ask them if they stole it? Wouldn't
I
surprise me.
think seen it.
Yeah, at home, huh?
No, like the one at the ice cream.
Oh, yes, that one.
Where'd you lose it?
In here.
In school?
Which
Yeah,
one?
I don't know, it's on Friday.
Yeah.
That's not the first time you lost something, is it? Just saying. Continuing.
But where can I find?
Where did you find your last thing you lost?
Didn't find it.
Which one?
Oh, which one? I don't know, what did you lose last?
Terrible.
I looked twice.
What did you lose twice?
The first one
Yeah?
had also the bag.
Yeah, the bag,
The
okay.
second one is the bag, the penny bag.
Yeah, and where did you find them?
I don't know.
You didn't find them. I think you have your answer.
Didn't you also lose your wallet?
There's a pattern emerging. Right. Okay. I want you... Oh, he stole it.
I said wrong.
Wong took it.
He said wrong.
I just said 1.
What? Okay. I want you to define activity using a derivative. So look at the definition for activity and try to define it using a derivative. For example, remember, force is the rate of change in momentum. That is dp dt. So look at the definition for activity and tell me what you think it is as a derivative. Yes? This is derivative.
What is physics?
Yeah, no, this is physics. We put some maths in physics sometimes.
dA over d lambda.
No.
d lambda over d.
Okay. Hang on. In mechanics, force is the rate of change momentum. So that means force is also dp dt. So I want you to look at the definition of activity and give it to me as a derivative. What is the definition of activity?
The rate at which one stable equal decay.
Yeah. So what?
Decay over time.
Yeah. But what letter represents what? I mean, decay of what? What are you losing?
And
N.
D lambda N over
No, hi. So we're losing N.
Yes.
So we already know what the top is.
DN.
It's the
Yeah.
change Dn.
DA.
No,
DD.
dt. Dn dt.
DN.
Yeah. That is activity.
What?
So we could also define activity is the rate of change of n over time. And if n is decreasing, that's why this is a minus. Because the graph is sloping down. So this is another way to define activity as a derivative. It's the change in number of atoms over the time.
How would this, or what would this help us in?
The next thing.
So we need to
Well, it's going to lead into the next thing. Define the value of n or a at any time. We can use this by solving the radioactive decay equation. This equation does not contain time, so we first need to rewrite it, and then we can solve for a and n. So, what's the magic? Earlier I said a equals minus lambda n, right? But I also said a is dn dt, correct? So if I rearrange this, I can end up with this equation. Hey, does this look familiar? Of course it does. Why do we do this? Maths. ODE lesson. I can integrate here and here, and what do I get on the left? Log n. And on the right? Minus lambda t plus c. How do I cancel the log? E. So I get E. So I get n equals EC, E minus lambda t. Now if I put t as 0, I get n at the beginning, which I'll call n0, equals E0, and this is E0. E0? 1. So E0 equals n0, so I can put that back in there, and I end up with this formula. N equals n0, E minus lambda t. What shape is this graph? We did this in semester 1. No. Down. Why? Because this is negative. So what happens to the number of atoms? Decreases. But if I go back to this formula...
You did all of this to get to the graph.
No, this equation.
Yeah.
Yeah. What do you mean all of this? 1, 2, 3, 4, 5 lines, all of this. Likewise, if you remember that activity is the derivative, if I differentiate this in a similar way, you can get the formula activity is A0 E minus lambda t as well. These formulas are very familiar to you as physics students because you had similar formulas in the lesson on electricity. Remember? With voltage in the capacitor?
There's always an exam question about the AEKTUs.
Yeah, you had, remember E minus T over time constant?
Not that, I don't think that, but yes, I remember that.
You remember that, yeah?
Yeah,
So, you need the proof of this for the exam. This is one of the proofs that could be on the exam. Hey, hang on a second.
No, it's not.
No, you don't need it.
Video, guys.
No, sorry, did I skip a lesson from fields? I did. I didn't do the last lesson.
Kepler's.
Yeah, so, no. I just mean I have to backtrack to the last lesson in fields. I just realised I didn't do it because I was about to say, because this is one of the proofs on the exam, because the other proof we did last.
wow.
That doesn't matter.
But
No, it doesn't. Why does it matter?
can skip that lesson.
No, we can't, because I just said the proof is one of the proofs on the exam. So anyways, after lunch, what we'll do is we'll finish that lesson from fields we never finished, because when I said this morning, because we never started, yes. We'll do that later today after lunch, and then we'll continue with this.
Okay.
No
Yeah.
math.
Huh?
No math.
No, I want to get we'll do the maths tomorrow.
I have a question.
Is it good?
It's not about this.
Okay, let me stop the recording in case it's some more of your dirty jokes. Oh no. Well, you should write this down because this proof is on the exam.
When you say this proof is on the exam, what do you mean?
As in, they could ask you to prove these two formulas. Huh? 4 or 5.
Very much so, I gotta
You
do
can
it.
do it.
You want to take the hit?
You can at least get to the second time.
But what makes me sad is this is what we do in maths in the ODE lesson.
Are you gonna have lunch now or is it now?
Yeah, that's what I wanted to ask.
Really?
Yeah,
I'm
yeah.
having lunch now because I'm tired and hungry.
So I will come to you in the next hour.
Can't wait.
I formed a new formula for physics,
What?
for pressure.
No, it's wrong, right?
No, it's not Fangli.
No, I think I thought about it later.
It got me thinking for like 2 days maybe.
Trust Lee. What's his formula?
No, he thought like the average temperature, you can add these two and divide it by 2.
Average temperature what?
Average pressure.
Average pressure.
Of what?
Like two.
Like,
two
let's say there's a
point-
container, yeah? Like, a container A, container B, they have different volumes and different temperatures. And then they
Combine.
open, and they would
Yeah.
like find the number of moles. So, and they open the thing that's
Yeah, yeah.
breaking down.
Yeah,
And
that
so
was an
the
exam
pressure is
question.
equal. Yes, the pressure is equal in both containers.
It will be, but it won't be the average of the two.
But then I got the average, and that was the exact same number.
I know.
Pressure.
That question,
Tell me about the...
Oh yeah, it's a bottle, the pressure is 1 pascal.
Yeah.
And the pressure is normal,
1 atmosphere.
Yeah, if you open the bottom, the pressure won't be the add and it's go to
pressure of the entire universe will
yeah.
increase.
But you
Maybe-
get the same
Yeah, maybe the
exact answer.
when these two volumes
On
are
that,
close,
on those
maybe.
numbers.
well, I'll do that question. I was unhappy with the very last part of the question. Was that the part that is about the pressure?
Yes, the pressure, and like it first asked us to find the number of moles, and then
I'll look at that one. There's something a bit
Like,
unusual about that question.
I get how he did it, like the formula, like that's what I